Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. In my earlier video on quadratic equation, I had given three different ways of solving a quadratic equation. One of them was using the quadratic formula. Now we will elaborate a bit more on how to use that quadratic formula and how to identify that what will be the nature of roots upfront without going through the entire solution of the quadratic equation using quadratic formula. The standard quadratic equation is ax square plus bx plus c equal to 0, where a cannot be equal to 0. Now, discriminant of a quadratic equation is given in terms of d, which is equal to small b square minus 4 times a into c, where a is the coefficient of x square and b is the coefficient of x, c is the constant. Now, if you are able to find the value of d using b square minus 4ac for any quadratic equation, you can predict that what will be the possible nature of roots or solution of this quadratic equation. If the discriminant comes out to be equal to 0, the roots will be equal. Mind it that there will be two roots, but both will be equal. Suppose the solution of that quadratic equation is, say, 2, then there will be two 2's will be coming as a solution. If the solution is 3, then 2 times 3 or 2 3's will be coming as a solution. If discriminant is greater than 0, then the roots will be real and they will be distinct, different. For example, one root may be 2, another root will not be 2, rather it will be maybe 4 or 5, but it will be different. So both the roots will be distinct and they will be real also. If the discriminant is less than 0 though, then the roots will be imaginary. You cannot find a real root for that kind of quadratic equation or a real number which can give the solution of that quadratic equation. So just by identifying the discriminant, you can predict that what will be the nature of roots. Let's take one example. Suppose this is a quadratic equation, 7x square minus 6x plus 8 equal to 0. If we compare that with the standard quadratic equation ax square plus bx plus c equal to 0, then in this case a will be equal to 7, b will be equal to minus 6, and c will be equal to plus 8, right? Therefore, the discriminant in this case will be equal to b square minus 4 times a into c, and that will be equal to minus 6 the whole square minus 4 into 7 into 8, which will be equal to 36 minus 32 into 7, that will be 2 to 4. Okay? Yes, that will be 2 to 4. Okay? Yes. And therefore, this discriminant will be equal to 8 and 11 minus 3 is 8 and then 188. Okay? Yeah? So what we are finding? We are finding that discriminant is coming negative, minus 188. If discriminant is coming negative, then the roots or the solution of this quadratic equation will be imaginary. We will not be able to find any real solution of this quadratic equation. No need of proceeding forward to finding the roots using quadratic formula. We know that the solution will not be real, it will be, roots will be only imaginary. Okay? If we have a different quadratic equation where we find that d is coming greater than 0 or positive, Then we will find real roots, but those will be two distinct, different roots. If the discriminant is equal to 0, then the real roots will be possible, but both the roots will be equal. Okay. Let's try solving this problem based on this concept. Find the value of small p if following quadratic equation has equal roots. So this is a quadratic equation given. Now let's compare it with standard quadratic equation, which is ax square plus bx plus c equal to 0. What we get? A is equal to 4 plus p, b is equal to p plus 1, and c is equal to 1. So let us find the discriminant d, which is equal to b square minus 4 times a into c. That will be equal to p plus 1 the whole square minus 4 times a, which is 4 plus p, into c, which is 1. So this will be equal to p plus 1 the whole square will be equal to p square plus 2p plus 1, right, minus 4 times 4 plus p, that is minus 16 minus 4p, right? Minus 4 into 4 is minus 16, minus 4 into plus p will be minus 4p, and 1 is multiplied, so there is no change, right? So with this we will get p square, and this is 2p, and this is minus 4p, so this will be minus 2p, and this will be minus 16 and plus 1, so this will be minus 15. So we get the discriminant is equal to p square minus 2p minus 15. Now it is given that this equation, quadratic equation, is having equal roots. Therefore, discriminant will be 0 from what we have just explained. So therefore, this leads to p square minus 2p minus 15, which is equal to 0, right? Now you notice that this itself is a quadratic equation, okay? Now if it is a quadratic equation, we can use the quadratic formula. We can use any of the three methods which we have discussed in the earlier video, but just to further establish this concept, we can use the quadratic formula to find the values of p. So let's do that. Maybe I'll just rub this out just to show that how do we use that concept. Now in this particular case, this is also a quadratic equation. So let us now compare that with the standard equation of ax square plus bx plus c equal to 0. When we compare that, the value of a is equal to 1, value of b will be equal to minus 2, and value of c will be equal to minus 15, right? So then, if we find discriminant of this quadratic equation, what we'll get? We'll get b square minus 4ac, that will be equal to minus 2 the whole square minus 4 into a into c, which is minus 15. That will lead to equal to minus 2 the whole square is 4, and minus becomes plus. 15 into 4 becomes 60. So this becomes equal to 64, right? Now we can use the quadratic formula. So in this case, the value of p then will be equal to minus b plus minus square root of d divided by 2 times a. If we put the values, then we will get minus, and b is equal to minus 2 plus minus square root of d, we got 64, divided by 2 times a, and value of a is 1. And therefore, we will get minus and minus 2 becomes 2 plus 2, and plus minus square root of 64 becomes 8 divided by 2. If we break it up, then we will find that it will be either 2 plus 8 by 2 or it will be 2 minus 8 by 2, right? So, it means the value of p can be either 10 by 2, which is 5, or minus 6 by 2, which is minus 3. So, either p is equal to 5 or p is equal to minus 3 will be the value of p for which this quadratic equation will have equal roots. Okay? So this is how we utilize the concept of the discriminant. It is always recommended that whenever you are trying to solve a quadratic equation using quadratic formula, you better first find the value of d. Because the moment you find the value of d, you will be able to predict that what kind of nature of roots I am going to get. And in this particular case, just notice that d is positive. So therefore, we are getting two distinct roots which are real but different. One is 5, another is minus 3, right? Now, if you use any of these value of p, then you will get a quadratic equation which will yield to equal roots in terms of the solution of x. Okay? So this example is kind of pretty good example in how to use the concept of discriminant in solving a quadratic equation. Hope it is clear to you. Thank you.